Hey, everybody. So we're going to talk a little bit more about the location of data, in particular the five-number summary, and we're going to compare it to some of the things we've already done. So let me just remind you of a few facts before we dive right in. So our five-number summary, this is a collection of five numbers that help us understand, let's say, the shape or the location of, when we say location of data, what we mean is the shape of it when we look at it. This will be more apparent maybe in a minute when we compare it to a histogram. But those five numbers are the minimum, the smallest value. The maximum is at the other end, the largest value. And then in between, we have the three quartiles, Q1, Q2, and Q3. Remember, that means Q1 is the 25th percentile. Q2, sometimes known as the median, is the 50th percentile, and Q3 is the 75th percentile. And what that means is there's approximately 25% of the data between those five, between those five numbers, right? So between the minimum and Q1, there's 25%, between Q1 and Q2, 25%, Q2 and Q3 and the max, or approximately, right? When the data is not large enough, it's hard to actually divide it exactly into 25% chunks. So let's go ahead and take a look at something. I want to share some data with you guys. So this is a little data set that I made, I don't know, a couple years ago. I just went to a neighborhood. I used something like Zillow at the time, something that listed home prices. And so I went to a neighborhood and selected 30 homes. And I got two pieces of information for each home. So in these two columns on the left here, I gathered how many square feet was the home and the price in thousands of dollars, right? So you can take a look at this. I'll make sure to link this in the video. And then what I did was create a third column, thousands of dollars per square feet, right? So I just took the price in thousands of dollars and divided it by how many square feet. So for instance, this one is 1.73 thousands of dollars, so almost $2,000 per square foot. Something like this one is $300 per square foot, 0.3 thousands of dollars per square foot, right? It might be a funny unit, but otherwise the numbers are just too big. So this just gives us some nice numbers to deal with, right? And if you look closely, you can see how I did this. I had to enter this data by hand. This is just data collection, these two columns. But over here, I just took B2 divided by A2, the price divided by the square footage, and I just copied that into all these rows, all these cells. It automatically updated the numbers to make this computation pretty simple. Okay, so this is the data I'm going to take a look at right now, this price per square foot in thousands of dollars. So the first thing I created is something you're familiar with now, is a histogram. Okay, so I did these buckets that are each 0.11, right? So you can see how many homes are in each price, and you can see that our homes are very, very clustered down at the left end, right? Most of our homes, almost all of the homes, are between 0.20 and 0.64 thousands of dollars per square foot, right? Not a huge range, somewhere between 200 and about 600 dollars per square foot, versus these other much higher categories, right? We've got just 3 of those 30 houses spread out that way, right? And so looking at this histogram, right, if I just told you something like the smallest and highest value, we might see, we might not get such a clear picture. What we really see in this histogram is how much the data is clustered down at this low end. So then I did something else. I created the 5-number summary over here. Okay. So if we look at this 5-number summary, the minimum is 0.23, Q1 is 0.32, Q2 is 0.45, Q3 is 0.61, and the maximum is 1.73. Okay. This tells us a very similar kind of story. So I want to try to get into how we can start understanding these 5-number summaries. I'm going to do it with some words right now, and then we're going to do a little exercise in visualizing these things. So let me switch over to paper for a second. Let's take a look at, all right. So I just want to copy down my 5-number summary. I had a minimum of 0.23, Q1 was 0.32, Q2, Q3, and our maximum, we have 0.45, 0.61, and 1.73, right? Remember what these numbers do. These numbers split up the data into chunks of about 25%. That means between these two numbers, there's about 25% of the data. 25% of data, 25% of data, and 25% of data, okay? But notice something. This first category is only about 1/10 of a unit apart, right? From 0.23 to 0.32, right, 0.09 worth of data, there is 25% of the data. This is a similar distance here, slightly bigger, but still fairly similar. This one is also pretty similar. There's 0.13 difference here, 0.16 difference here. And then we jump up about 10 times, almost 10 times as much, right? There's a huge difference between here with the same amount of data in between them. This tells us how much more crowded it is at this end, how many more data values are close together down here, and how spread out the data is up here, right? The difference between the minimum and Q1 you can think of as like the size of a room. And there are this, and then, so the size of the room here is 0.09. The size of the room here is 1.12, right? So the room from minimum to Q1 has a size of 0.09. The minimum, the room from Q3 to the maximum has a size of 1.12, right? This is more than 10 times bigger, but they have the same amount of data in them. They have the same number of data values in those ranges, right? So each has about 7 pieces of data between those. So there's about 7 pieces of data between 0.23 and 0.32, and about 7 pieces of data between these two numbers, right? So that means it's much more crowded down here, okay? And much more spaced out up here. And so we get confused by this. In the fact that these numbers are closer together, that they're a smaller difference, means there's more data packed, well, the same amount of data packed in there, but it's more dense. It's more packed because it's a smaller room, right? You've got 4 rooms that all have the same number of people in them. The smallest room has people standing shoulder to shoulder. The largest room can have people standing very, very far apart, right? Which is exactly the same idea we were getting from our histogram. Right? Again, you can see that there's all this data packed in down at the low end and very spaced out at this end. All right. I want to do one more exercise with this 5-number summary in this. I do just want to point out, as long as I have this spreadsheet open, how I computed the minimum, the maximum, and the quartiles. If you look up here, remember this shows you what I actually typed into this square. I typed quartile, which is a command to find the quartile. The next thing typed is which data values I wanted to find the quartiles for. So I'm telling it to look at C2 down to C31. And then which quartile, that number 1 says find the first quartile. This one has exactly the same thing, except a number 2, a number 3 for the third quartile. And then minimum and max have, excuse me, I clicked the wrong thing. Maximum, there's a command, max, and minimum has the command minimum. So those are nice ones for computing these quickly without having to do too much organization. Okay, So last thing for this video, let's go back to a piece of paper. Here we go. Okay. So I'm going to create a little graphic of this 5-number summary on this paper here. So I've already done a little bit of work. I just drew a number line from 0 to 2, and I marked off every half unit with numbers, and then I even marked off the quarter units down here, okay? So here's what I'm gonna do. I'm gonna look at each number of my 5-number summary, and I'm gonna make a vertical bar where it is just below my number line. So for instance, the minimum 0.23, this is 0.25, 0.23 should be just below it. So I'm gonna draw a vertical bar there. 0.32 is a little bit above it. 0.45 is getting close to 0.5, so maybe somewhere about right here. 0.61 is just on the other side, somewhere maybe about right here. And then 1.73 is all the way up almost to this value here. All right, so there's my 5 numbers. I look at the middle 3, and I make a little box around them. And then I put a little connective line out to the other 2. Okay. This is something called a box plot, or sometimes a box and whisker plot. Okay, so this is just a little device to help us visualize this 5-number summary, right? So there's really no new information, but it's a nice way to look at it. And kind of what I was saying up here above about the size of these rooms. Between each 2 bars lie the same amount of data, right? So for instance, there's about 7 pieces of data in between each of these 2 bars, right? So if I just drew this in visually, there's 7 pieces of data in there. Seven pieces in there, and then we can see how much more spread out the data starts to get in this other one, right? I'm putting it in there fairly arbitrarily, but you get the idea that the data gets more spread out as the room gets larger, right? As there's more space between the 5 numbers, between any 2 consecutive of our 5 numbers, the data between them is much more spread out. So we see the data concentrated at the low end, spread out on this high end up here, right? Which is good for people trying to buy homes, though this data is several years out of date. I imagine things have changed quite dramatically. Another thing we might look at, when we have data that's much different than the rest of it, this one is called, this maximum here, for instance, is very, very different from the rest of the data. You may have heard the term outlier before. We might be interested to know, why is there a piece of data that's so different than the rest? And these box plots can help us identify them to some degree, right? The fact that there's so few data up here and 75% down here might tell us there's something interesting. I haven't investigated the neighborhood where I got the data from, but one guess might be that that home that's significantly more expensive than the rest is much more modern. Maybe it was something built in the last couple of years where the other ones are older homes. And so it has a very different kind of price profile. Or maybe it's a neighborhood where there's one particular place where there's a better view than the other homes might get. And so that one has a significant price jump. Or maybe some combination of those, or something I haven't thought of yet. But we'll go into more details about those later. But these box and whisker plots are things that you can, obviously computers will generate them more often than humans will. I don't usually draw them out. Canvas, in fact, when I look at grades on exams, produces a box and whisker plot for me to give me a sense of how the grades are distributed. I'll do one last thing. I think that's the 3rd time I've said this is the last thing, but I do want to do one last thing. Let's look at a computer-generated version of this graph. We'll just take a second. I entered the values in before. This website I found, nothing particularly special about it, but it produces box and whisker plots. They happen to do it vertically, but you can see the same thing, right? There's our 0.23 and so on. And they've made this box and whisker plot, and you can see the spread of the data here. Anyways, that is it for this one. I will see you next time.